Welcome everybody. I'm super excited to have so many of you here for our third Rust Munich Meetup. As I have learned, we already had two before, but those were just for drinking. Today is the first for drinking, and having a talk.
Rust can be fun without alcohol.
Yeah. So let me just briefly introduce Codecentric. So for those of you who haven't been here, but I already heard that a lot of you have already been here for various other meetups like Scala or Ruby or something else. Codecentric is a Germany-based consultancy. We have offices in Munich, obviously, and a couple of other cities, and we are working with the greatest technologies. Well, we are not yet working with Rust, but hopefully we are getting there. We are working with Clojure, Scala, and a lot of other cool languages and other technologies, of course. So, by the way, we are hiring, so if you're interested, just let me know, or some other Codecentric guy. We don't wear Codecentric t-shirts, that's a problem, huh? So, who's from Codecentric? Okay, great. So you can either talk to one of us or just go to our website and sign up. So yeah, without further ado, I want to introduce you to Markus Jais, who will give our first ever Rust Munich talk. So give him a hand. And as a final sentence, I had to apologize. I had to leave early, around 8:15, so probably, maybe even during your talk, because I got to travel to Frankfurt. But enjoy this evening, have a couple of beers after the talk, and yeah, make sure this is all a great experience.
Enjoy the trip. Okay, hello everybody. It's great to see so many people interested in Rust already, even if it has only been stable for a couple of months. First, before we start with the talk, this is, Heiko said, this is the first meetup where we actually have a talk. But of course, we want to have more. I have ideas for talks, but I won't have the time to do one in the next 2 or 3 months. So any ideas for talks about us, if you're willing to give a talk, please let either Heiko or me know. It doesn't have to be a 2-hour talk. It can be something like 20 minutes. Like things I really like about Rust or stuff that scares the shit out of me. Whatever, if there's something you want to talk about Rust, or even, let's say you ported a Google Go project to Rust or a Scala project to Rust, and you can say, well, I learned this is good, this is bad, whatever. Let's schedule a talk, find a location, and we all can learn more. I myself am learning Rust. I'm not a Rust guru, but I learned that if you have to explain something and you really want to understand it, maybe some of you guys are learning, I don't know, German, so if you explain German grammar to your coworker, you learn it. Although this is significantly easier than German grammar, I promise. Let's get started. All the slides are on GitHub. I'll show you the link at the end. Also the sample code, it's all on GitHub. So anybody who wants to have a deeper look, or you can also contact me via Twitter, or just ask me questions or send me a message via Meetup. System programming is normally something, this is close to the hardware, close to the operating system. So you know how to lay out the memory for your program. You want to talk to low-level operating system calls, or maybe interact with the hardware directly. This is often very useful if you want to write high-performance systems like web servers or databases, something like that. You want to avoid things like a garbage collector or using more memory than it's strictly necessary, etc., etc. Traditionally, this was done mostly in C, C++, which isn't bad. And it makes sense because Linux and almost all other operating systems I know of are actually written in C. If I'm talking too fast, I tend to do that. Please interrupt me and I'll try to speak a bit more slowly. If I'm telling nonsense, please also interrupt me so I can correct and you don't leave this meeting with wrong information in your head or the impression that I'm an idiot. Okay, C is a very low level, but the whole Linux system interface is C. The system calls, they all look like C functions. C++ is often a much more powerful language. You can have objects, generics. The standard library for C++ is significantly more advanced than the one that comes with C. And the latest versions of C++ are so much better than the older versions that you can. Unless, of course, you use Rust, which is what we're talking about. Sometimes people use Python or Ruby, which have interfaces for most system calls, like, for example, fork, or most others are available. Relatively easy to write a wrapper around C functions in those languages, but these are normally not used for low-level system programming because you don't have that much control about hardware. For example, in Python you have an integer, but if you want to be as memory efficient as possible, probably not what you want. In Rust you have 8 different types for integers alone. 8-bit, 16-bit, 32-bit, 64-bit, both signed and unsigned. Like be as efficient as possible. This is actually pretty cool. So Rust is new, and I think it's one of the best choices. Swift 2 might be an alternative with making it open source and porting it to Linux. Right now you're tied to Mac. Rust itself is developed, as probably most of you guys know, by Mozilla. I'm not getting into too much, but to give you a quick history, written in hundreds of lines of C. Or when they started, it was the perfect choice for writing a browser. You don't want a browser that suddenly does a garbage collection in the background and you can't do anything. And it should be as fast as possible. You need to access low-level operating systems, you do concurrency, you want to access the hardware. For I don't know, within Firefox, we're related to illegal memory access. Both either memory leaks, or crashes like segmentation faults, or in the worst case, security holes, like buffer overflows, where suddenly somebody managed to introduce some bad code into the buffer of your Firefox, and then in the worst case might steal some of your data. Rust was developed to prevent all this. They wanted to say, okay, we want to implement one as a library. Rust can be as low level as C, but it also can be as almost. It takes a lot of ideas from languages like OCaml or Haskell, although it doesn't go as far as Haskell does, so sorry to disappoint those guys. But it's nice combinations. We say from no memory leaks, no illegal memory access, but it goes even further, because as we're later going to see, Rust also allows you to make sure that your multi-threaded code is safe. When you, for example, accessing a hash map with 5 different threads, both writing and reading, Rust can make sure that the code is safe. But the shortcomings of traditional languages, with C, you have, of course, memory leaks. Everybody probably has had to deal with those once in a while. Undefined behavior, something valid, something good. Seg faults, security bugs, we talked about that. And it is very low level, but if you don't want to go down the Rust road, or not yet, make sure you look at C++ 11, C++ 14. It is much better than the older versions. The JVM is great. I like the JVM. I've been using it for more than 10 years. My Java might not be that cool, but there's Scala or Clojure. So the JVM is really cool, but for certain applications, it has some drawbacks. You just don't have the control about, for example, memory layout or hardware. There is overhead. All the safety constraints, they require a certain overhead. That is often very small, and the JVM is extremely efficient when it comes to optimizing code during. It's still there. Garbage collection is pretty cool if you had to program with C++ for many years and then started with JVM. Life was great. And as long as you don't allocate more than 4, 8, or even 16 gigabytes of RAM, your life is still great. But now, if you look at some of the NoSQL databases like Cassandra or Neo4j, or big data solutions like Spark or Apache Flink, they all go to extreme to manage the memory off heap. So there's sunmisc unsafe and other weird creatures, what they use C, and with JNI or JNA, this is overhead. Garbage collection is great, but there is overhead. And sometimes you do not want that. So either you have to go to a lot of extremes to get this done with the JVM. It might still make sense. For example, I talked to the Neo4j guy, and they still would prefer Java over C++, probably because mostly the Java ecosystem is so much more advanced than anything else. Tooling, libraries, so it might still make sense to use Java and go to the extra language and manage the code somewhere yourself with SunMISC unsafe. But sometimes even that might be not an option, it might be too painful, and then you want something more low level. I already said that if you want to use C++ or C version, get it C or Clang compiler and or Visual Studio if you're on Windows, and use the latest version. It makes your life much easier. Rust, why? Rust is normally fast. If it's not fast, it's probably our fault because the compiler is really good and they can already optimize. It uses LLVM underneath, so the binaries that are produced are very efficient. And they're working on improving it. The compiler at the moment is not as fast as, for example, in Google Go, but it is already pretty good, and it has already been made faster since version 1.0. It can be very different integer types. What more could you want? You can use, if you really have to, use something that's called unsafe, where you do not have all the Rust guarantees in your basic code. You could even create a seg fault. I show you how I did this with an open source project. But this is just if you really want to. Normally you don't have to do it, and even for example the Rust unsafe code at all. It's really for people wrapping C libraries, or maybe people writing a standard library and writing something like a vector or a hash map, because they really know what they are doing and they use this low-level stuff for performance OpenSafe code. And if you use a vector or a hash map, it will completely safe from a memory point of view. Otherwise, anything else would be a bug in the standard library. Rust is, as I said, can also be very high level. I'm not going into too many language features itself. We're looking more like Linux system programming stuff. But if you probably, who has developed Scala? Or at least, that's quite a lot. The others really should do it. If you know Scala or maybe another functional language like OCaml or Haskell, many of the ideas in Rust will look similar. They have pattern matching, they have a lot of functional libraries, and they use map, and there's not flat map in Scala, it's called something else. I think I forgot the name, but a lot of functional ideas are in Rust. So it looks often like a high level function. By default, everything in Rust is immutable, like when you use Scala and using a val. But sometimes mutability is necessary for interfacing with C. Mutable variables are just more efficient than immutable stuff, which you might need to copy or have some overhead for a persistent data structure. So Rust defaults to immutable, but does not force. And as already said, Rust doesn't have a garbage collector. It uses reference counting and other mechanisms. Once memory is no longer used, it's immediately freed. It is not like in the GC, memory is no longer needed, it is freed immediately. And the Linux kernel can allocate it for another variable, for another process whatsoever. Same on Windows. Rust runs not just if they want to write Firefox, at least the rendering engine of Firefox will be at least partly implemented in Rust. So it also runs on Windows and Mac, and I think FreeBSD, there's no official release, but I think it works in FreeBSD as well. So FreeBSD, there's more. As I already said, Rust is normally memory safe. Rust has no null. So everybody probably with Java or Scala has had to deal with null pointers once in a while. They aren't that much fun. Now you have optional in Java 8, but if you have a function that returns an optional, you could return null as an optional. That's of course stupid, but the compiler is doing something stupid. Rust doesn't even have null. If you go to that unsafe block, you could check if a low-level pointer is null, but you cannot not allocate it. If you have allocate a variable, it's initialized. It's not pointing to some weird memory location. And if it goes out of scope, it will be cleaned up, and there will be no other reference pointing to that memory anymore. So it's not possible that you will access memory that has already been freed, and it's not possible that this memory is still hanging around when it's no longer needed. Everything else will be a compiler bug. We have safe concurrency. Safe concurrency here means you are protected from data races. We'll later, but this is pretty cool because this is something that even Java or the Scala can guarantee you. If you use something like Akka, Heiko will probably JVM, then you're normally safe from concurrency bugs, but there's no guarantee. Rust make sure with the compiler and some intelligent library, use shared mutable state and access it from several threads. You cannot do this unless you make sure it's protected by lock. Rust has a very strong type system. You can do something like add string and then something magic might happen and you have no idea what the output will be, it will just not compile. It's a very strong type system. The standard library is already pretty great. It has most of the collections you will ever need, vectors, hashmap, network I/O. Right at the moment there's only blocking I/O. There might be non-blocking I/O in the future, or maybe not. That doesn't mean you can't do non-blocking I/O, also like ePOL on Linux. So you can, but the Rust guys are very conservative when it comes to adding new features to the standard library, because if you add something too early and in a state that's in an immature state, you may add something to the library that will be very hard to get rid of, like thread stop in Java, for example. It's still there. So they are rather reluctant to add new stuff unless it's really stable. A lot of the features in the standard library are still marked as unstable. And if Rust, it won't compile if you use those features. You need to use an unstable version because they're telling you, no, this is not stable yet. You can play with it, but not with the stable version. At least this was changed this. But I like this a lot. I think it's better to evolve the standard library slowly instead of putting everything in it and then ending up mess. And a lot of stuff are now implemented outside of the Rust standard library as an open source project, like futures. They had futures in it, unstable, and they actually I can show it to you, or you can believe me. What is wrong here now? Oh. Crap. How do I know when the F11 is bound to an Ubuntu? Any idea? Well,
You can click on it. Yeah, just click on it.
Oh, I can just. I tried that. Thanks. Okay. Just want to show you that you can. Already gone. Yeah, that's probably they already removed it. It must be in here, I think. API docs. Yeah, here we go. Futures are nice, unless it's crappy as in Java 6, but even Java learned it in Java 8 has great future support now. Mainly they took the ideas from. See here, they deprecated it because it does not match the quality of the standard library, and they will prototype it outside. And maybe once they have a really cool version of futures, I like this a lot. It's definitely better than adding a lot of crap to the standard library that everybody has to use. So, but there are projects on Crates.io. That's where you can find all the Rust libraries that already implement futures, or you can play with them. So now back to Firefox, and again I can do, So, where is it? Here we go. And the community is pretty great. Whenever I have a question, there's users. You'll always get an answer. Everybody is very friendly. No insults or whatsoever. So let's look at, who knows what fork does? That's pretty cool. Everybody almost, that's very good. That is C code on a Linux system or any Unix system. If you call fork, you're creating a child process. Basically, and what fork does, fork has two different return calls. Your parent process, it will return the process ID of your child process. Every process in a Unix system has an ID, which you can use, for example, if kill -9 process ID, then it's dead. If it returns 0, then you know you're in the child process. This is not a very exciting example, but if, for example, you use this when you implement a shell. A shell, when you type something like cat, some file, they normally fork a new process and then execute the command. You could use this in a web server. For each new connection, you could fork a child process and execute. Why normally you would use something like a process pool, because creating processes, although pretty efficient on modern Linux system, is still overhead. The processes are somewhat more expensive than threads because threads share memory. Processes only share memory when it's read-only. Once you write to the memory, there's copy and write. Also, the latest Linux versions, as far as I know, have even optimized this. But there's still some overhead. But it's pretty cool. But as you can see, what you get back here, PT, this is basically an int. And you have to check for those numbers. Straightforward. But you could easily make a typo here, whatever. Now let's look at how Rust is doing this. This comes from a library called Unix-Rust. It's a library started by a guy called Carl, I think Lurch, or Lurchy is his name. He's very active in the Rust community. He's also working on the non-blocking MIO library. Great stuff. System calls like for Mac and for Linux. And here we use fork. And in Rust it's better, I think, than in C. First of all, what you get back is really a process ID. And you can match, or actually you get back a result. Who knows in Scala, try, success, failure? Who has used this stuff? Quite a lot, cool. This is a similar idea here. Or you basically say, I try to fork. Normally that works. And what I get back is a result object, and that has basically, it can either be okay or an error. And I'll try to show you the structure in a moment. So what you do, you match this pattern matching like in Scala or Haskell. If you, this is actually, you cannot type the wrong integer here. Like larger than 0, larger than, maybe you say smaller than 0, and then something weird happens. That cannot happen here because you need to all this well, otherwise it won't compile. Here we are in the child process. We exit, or we are in the parent process, and then we can match on this parent enum and get the pit in it. That's pretty cool, and then we call those two functions, get pit and get parent pit. You could do error checking on all functions. Most functions in Unix-Rust return a result. Those two don't. I added them myself because the man page says those functions never fail. So they do not even on Linux return an error code. If you have an error, basically just saying it's like exit. The process stops, prints this error message. If you cannot fork on a Linux system, well, you're screwed anyway, so nothing else to do.
So there are two mentioned, both constructors, or what do they describe?
I'll show you this. Oh, again, I have that problem again. No, that sucks. So, just a moment. I cannot mirror the display here because for the camera, so it's a bit more awkward, but in a moment. So, where is it? Yeah, I have a mouse.
There was something.
There was something, yeah, there should be something. Up here. Yeah, then the talk would make, it should be there. Ah, there it is. Sorry, that's why I use a lot of PowerPoint in the office. That's actually, where is it? I want to make it smaller. In there. It sucks when you don't see what you're doing. No? That's the problem with the beam. So, sorry, a moment, I'll get this working. Here we go. Now here we are. Don't make it full screen, it could hurt. So, this is the Unix-Rust open source project, the latest. And here we go to, where's the mouse? Here we go. So it's in here. So, here we go. So this is basically how this is implemented with fork. Here's fork. And this is an enum. And it has two members, either parent. And if you create the parent, the PID is inserted in the pattern matching code. And this is the child. So you cannot use a third. Like in C, you can match, I don't know, an infinite number of integers almost. That's not possible here. And here, this is the implementation. There's some helper methods, and here you see the real implementation. It's returning a result of fork. And this is either a parent or a child. Here, this is the call to I is actually in the standard library. They have very low-level wrappers around the C library. But they will return an integer like in C. And so you wrap this here. This is unsafe because it's accessing a C library. But there's no weird stuff going on, no pointer arithmetic whatsoever. So this is safe. Then they check the low-level return code from the C function basically and wrap it either in an error or in a child or in a parent. So this makes it much more type safe, so to say, and much easier to work with because the compiler will already tell you. Because in the C code,
for the return, you say return error and then okay.
I think it's not necessary. Open a pull request. Yeah, it shouldn't, I think, because there isn't one here, and the last statement is also about return. So I think this is can be approved. It's not wrong, but it's not idiomatic-wise. So thanks for catching this. I'll have a look and then I'll fix this. Or you, if you want, you can do it yourself. Go ahead. Okay, so. I think I'm not going into F11 again because this is just crazy here on this machine with the beamer. So I hope this is okay for you guys.
And just for the return, what's the semicolon? Because that line has a semicolon and the other ones don't.
Yes.
So if you use return, you have to use semicolon.
Yes, and if you put a semicolon here, Rust will the exact details. I'm sorry, I cannot explain. You probably have to look it up in the documentation, or we can have a look at it later. But there's a reason for this, but I'm not sure. So go back to the C code just for a quick moment. In C, you could, if you change this, you would do something smaller than 0, and then you would actually be here, but you are printing that you are in the parent process. In Rust, that cannot happen because you're matching enums and not an infinite number of integers. or not infinite, but 2 to the power of 32. So this is safer in Rust. And I think it's also, once you're used to Rust, it's easier to read. Any other questions? There will be more weird code, don't worry. This is a more advanced example. I'm not going to FE level again, that's just too crazy. And I look like an idiot when I don't know how to use my browser. Here again, we're doing basically the same thing, but here we're using wait pit. And what wait pit does, well, it waits for a process ID. In that case, we're waiting for the child process ID, which is normally what you do if, let's say, you're writing a shell. You want to actually wait for your child process to finish, and so you can just play, I don't know, status message or whatever. So if you have a web server and you fork a child process to handle the request, you might be interested in knowing that the child process is done. So you can either return it to a pool or get rid of it, depending on how you implement your server. And this is quite similar. It returns in C, it does return just an integer again. Here you have same, an enum, it's wait status, exited, and the pit and the status. And or you can have child is still alive. That should never happen, and you panic. And if you can't, if wait pit returns an error, then you're screwed as well. Then it's a simple thing to do is to panic, and maybe if you have this is a real life system, maybe inform, I don't know, logging systems or your admin via email or page or whatever that your web server is dead. Let's run this. I have this soft all this Linux, that's why I can't use a Mac. That would probably run on a Mac as well. So, so we have again that problem. Okay, here we go. It's it's different resolutions, that's kind of so. Computers are so easy to use. So, now I can see. That's in GitHub, by the way. That's how you structure a simple Rust project. You have this cargo. I have to show you this for just a quick second because it's just so cool. That's how you implement a Rust build file. You give it the name, the version, and you add dependencies here with just the library and the version. Star means use the latest version. And this is almost all there is to a Rust build file. So if you know Makefile or maybe Maven, that alone might be worth considering Rust. No terrible build tool anymore. How does this look like? Yeah, this should be fast, and I can show you this. What happened?
Just do capital R.
Oh, here we go. So here we go. We'll decide later if we put this on YouTube or not. Let's clean this because clean. Right, this is wrong. Tweet. This is how it looks like if you're writing binaries. You have just a source, you have a binary directory, and then you add the different binaries. These are all the code we're going to look at. And this is all there is to setting a simple Rust project. If you have a library, you normally use not the bin, but the source directory and the lib directory, and then you will structure your libraries in it. If you want to run one of these, you just do cargo, that's the name of the build tool, run binary, and then you give it the name. In our case, that's fork. It's compiling. If you're used to Google Go, the compiler is not that fast, but it's getting faster. So as you can see now, you're in parent process, exited with that process ID, and that's the child process ID. It's the other way around. And so it's relatively easy. And again, oh, where's my code? Here. It's all type safe because you have the enums and you need to catch the error. You could ignore it theoretically and do nothing here, but then it's your deliberate choice. You cannot forget not catching the errors. This will also discipline the programmer to make the code less error prone. Pipes on a Linux or Unix system for two processes to communicate with each other. This is for inter-process communication. This is still used a lot. Again, have a quick look how it works. This is C code. And we ignore that. This is just for exiting with an error message. Pipe in C returns an array with a pipe file descriptor, which is basically an int. And this is an array with two elements. This is the reader and the writer. And here you have the message. Pipe here got a pipe error. Then you fork. So you pass it, the pipe, and then it's writing the value in that array. Then you do the fork and you have a child process. You have to close the reading or the writing side, depending. Other process, you close the other side, and then you can read it. Here in C, you have to allocate the buffer, also the size and everything, and then you go to the standard out. Not very difficult, but again, I think in Rust it looks much cleaner. If you have a pipe tuple, this is a reader and a writer. Make sure you use them in the right order, but once you do that, there's no possibility that you mess them up later. In C, you could always use the wrong index for the array. I did that many years ago, and it cost me a couple of days to figure this out. Cannot happen unless you mess it up at the very beginning. You have a message, you fork, again you're in the child process. So here you need a mutable buffer. This is array syntax. It says you have an unsigned integer, which is basically a byte. You have 32 bytes in the buffer. And then you have to do strings in Rust are a bit strange for performance reasons. Then you have to turn this buffer into a string and then unwrap it. Basically says if there's an exception, panic, otherwise give me the value. Or not exception if there's an error. Rust doesn't really have exceptions like C++ or Python or Java. You read it and you print it. It's pretty easy. Message as bytes. Again, you unwrap it. That means you could catch the result of write, and then you would check for OK or error. Here we're just using unwrap, and that if it fails, panic and basically stop. So for production code, this is not maybe a good idea, but for this demonstration purpose, this is.
And so reader and writer, they have the same type.
They have the same type, yeah.
Is there any reason why it isn't like the output string? Because then you couldn't mix up the order.
Actually, let me check if they really have the same type before I'm telling you something more.
I think the pipe is bidirectional anyway.
Yeah, in that case, yeah, because it's bidirectional, you could change it. You could actually write to the reader.
How do you use the pipe?
Oh, nice pipe.
Okay, that's just how Unix works. That doesn't sound like a good argument.
It's, yeah, if you have a more, you could build more high-level constructs, like, for example, actors that sending, or you're later seeing channels where you can pass stuff. So this is just, if you want to use the low-level stuff, if you really want, it's safer than in C. That doesn't mean you should use it in all your programs. Here is pipe. Yeah, this is just two file descriptors. That's just how it is. Again, there must be some. It's all unsafe, so they're even initializing their memory uninitialized. So you need to do this in an unsafe block. In an unsafe block, basically saying to the Rust compiler, I know you are not giving me any guarantees, but I know what I'm doing. And as we programmers, we always know what we are doing. But if I write this code and assuming that you use this, you are safe and you get all the safety guarantees the Rust compiler is giving you. So, but I need to make sure that I don't mess this up. Particularly stuff like this, mutable pointers. But that is pretty cool because around this there's the safety net of the Rust compiler, and only inside here you're allowed to do stuff that are not memory safe. Rust needs to do this to interface with C libraries and something for performance optimization. It's the same in Python. Python you're normally safe for memory problems, but if you're wrapping C code, you need to whether your Python program will crash. So, Firefox.
I have a question. Is there any runtime on this Rust code? Like, will it generate like the same code as the C program?
I'm not really sure it will be exactly the same, but I made my way a lot. There's, for example, optional results. The end is just null in the assembler code. A colleague of mine dig deeper into the assembler code, and he always said it's amazing what's not there. Yeah. So they're really optimal.
Maybe let me add that they call out of their features zero cost abstractions. Yeah. That really means zero cost abstractions. I mean, it's not. It doesn't come at zero cost. It's a bug. That's how. Really very high-level constructs like the iterators in the collection library. So if they are not as fast as a native root, for example, it would be a bug.
That's I think the zero cost abstraction phrase was coined by Björn Stroustrup actually from C++, and the Rust guys obviously took a lot of ideas from C++. Fortunately, not all of them. There's I think Herb Sutter mentioned it during one of his latest talks. There are plans to create a library, I think at Microsoft, and they mentioned something of making it open source. I hope they will. That will give C++ 11 or 14 C++ programmers some of the guarantees. And he even offered to sit down with the Rust core developers to discuss lifetime and concurrency. And I hope they will meet because for sure both communities can learn from each other. It's not like it's C++ versus Rust or all these language wars, or some people like to do that, but I also liked it when I was young. It's old, but it's just ridiculous to say my language is cooler than yours, and yeah. That said, I really hope that they're learning from each other. Rust took a lot of ideas from C++, and if C++ is taking a lot of ideas back from Rust for future versions, we will all benefit getting better tools. So sometimes I mentioned writing a shell. You want to execute other programs. On Linux, there's a whole bunch of system calls for this. One is called EXECVP. Actually, I forgot what VP stands for. What you're basically doing here in this case, the idea is to run a file, cat, a program, on this file. So let's execute it first, and then we'll see what's going on, how it works. One process with exec. Go on. There's an unused import. I forgot to clean this up. So if you add something, use an import that's not used, Rust compiler will give you a warning, like Eclipse and Java, for example, and you can get rid of it. Here now you see an error message. No such file directed. That's the error message from the cat. And now where's the code? No, so it was, it exited, that was okay, but it couldn't Now it was here actually, okay. So calling the call itself was successful, it just couldn't call the program because it wasn't there. It's like when you have a shell and you call bin cat xxx, your shell doesn't crash just because the program calling is not there. But if we actually, I don't know. Run it again. Yeah, won't be anything there because the file is empty, but it ran without any problems. And here now it's status 0, which means it was successful. You could call it and 0, 1 indicated that it was an error. Not my code, but this is rather awkward to use. You have to do the wait pit and everything again. Then you have to create this weird to call it. This is all. It's there. If you want to use the low-level system calls, you can, but you don't have to, because in that case, the standard library has something a lot nicer. Standard process command. That's in the standard library. That basically does the same thing, and here it's much easier. You create your child process because it's a command. You say what you want to call, give it an argument, you spawn it, which basically on Linux.
It has multiple arguments by repeating $r.
Either that or you separate it by comma, I don't know. Or in that string, I have to look this up. I didn't try it actually. And again, you can see, you match the child process. If it's a child, you can wait. This is not the same child as we saw in the fork example. This is part of this process status. If it's okay, you can print the status if there's an error. And so this basically has exactly the same thing, but is a lot nicer.
Why is child?
Just a moment. Just to make sure that it's actually running. So, process. Code 0, so that was successful. I like actually something to that file. What's going on here? So it actually does what I'm telling you it does. So, why is this mutable? That's a good question.
Because wait takes a mute itself?
Probably. Let's look it up, I don't know. There was no one out there. I'm not used to the keyboard, I really. So, that answers your question. We just voila. It returns the output, and where's the wait call? I think it is. Child wait. Yeah, it takes a mute. So that's why it has to be mutable, unless otherwise you wouldn't be able to call the wait function. Waits for the child, return instead of. Oh, that's actually muting the reference to itself, to the struct, and that's why it needs to be mutable. But Rust prevents it from you passing it to another function. We could change it, for example, so you're still safe, despite this being mutable. So it can be even shorter. Unwrap or else. As I said, unwrap normally does return the result that's wrapped within an option or in a result object, or it does panic. But you can also say, I take some panicking manually, but you could also do something else, like just say, okay, print an error message, ignore it, send an email or whatever. So in the end, this is much easier to use, in my opinion, than using the low-level EXECVP or exec functions. So if you want to start external processes on a Linux system, use the standard library, unless you really need the low-level control, whatever. That would run on a Mac as well, without any problems. And it should also run on Windows, actually.
Is this error, the pipe notation thing, is it like a lambda or something?
Well, that's basically what you're passing into the lambda. That would be like, if you know Scala, that would be like error and then arrow, and then panic, and then using that arrow variable again. Just a different syntax, more like Ruby-like, where you have those pipe symbols. But Rust supports lambda similar in a way that Scala does. So, concurrency. Concurrency support is in the standard library. It's mostly low-level stuff right now, like threads. The memory safety stuff also applies to multi-threading, which we're going to see in a moment in the examples. As I said, mostly low-level stuff. More is coming. And creates there are libraries for futures. There's one library, also I'm not sure if it's still under development, for actors. Others are developing, like we said, non-blocking AO with coroutines, and a lot of other stuff is under development right now. Some are also working on thread-safe data structures that are lock-free. For example, if you know Akka, the actors have a mailbox, and they are implemented using Java util concurrent link queue, which is a lock-free queue. By default, you can use something else, but the default is lock-free. And a lot of stuff is coming, but right now it's the basic. But the basic stuff, what you need to build those higher level abstractions, are already there. This is broken deliberately. I have a string, or I have a vector of strings. This is a macro that helps me to generate a vector. And I have 3 strings in it. A string is it. Then I create a vector for threads, and I iterate over those strings. I add the threads to my thread vector, and here I print each individual string in that vector. In the end, I join, so my main program doesn't exit, but it's broken. Does anybody see the problem? Well, sorry, I put the comment in it. I shouldn't have done that. Well, let's compile it just for fun. It was so the gray I couldn't see it. That's why. So it's called threads. Broken. Can everybody read this? Capture of moved value string. So the compiler says, translated, this means this word move means use what's around it, move it into that closure. So that you cannot move this in here because something else might still access it. And if it's moved in here, compiler doesn't know. No, that's not the reason. There was a different program which I didn't include in the talk.
Well, you're trying to move it into several.
Yeah, that's the reason. Yeah, exactly. You can move it only once, and what I'm trying to do here is a loop, actually moving the 3 threads. Thanks, and that doesn't work because these threads they would have 3 different or you can move a value to another function on another thread only wants, because that's what move actually says, like in C++11. You cannot copy it here, and it wouldn't be. So if you want to use this string in 3 different vectors, you cannot move it to the first, because then you can use it in the other 2. But you also need to make sure it doesn't go out of scope when the threads are still running, when the main thread is already gone. For example, if you don't call this join method. And the solution is, that's actually pretty cool, ARC. ARC stands for atomic reference count. If you use that vector, which is heap allocated, in 3 different threads. In Java, a garbage collector would take care of this and say, okay, this is used in 3 different threads, and once, or in 4 with the main thread, and once this is done, I'll mark it for removal later. And the garbage collector in Rust, it doesn't work there because there's no garbage collector, because it's defined in the main thread. If you pass it to a bunch of other threads, you can only get rid of this this memory once all the threads are gone. So you need a reference counter, and you increment it each time you use it, and you decrement it each time the value goes out of scope. There's an RC type in Rust without the A, which is a but that's not thread safe. A stands for atomic, ARC, so this is an atomic reference counter, and that means this is thread safe. So each time you pass it to another thread, the increment is actually atomic. They probably use something like compare and swap underneath. It needs to be thread safe because a normal plus operation, even in C, is not thread safe, because plus plus is more than 1 instruction on the CPU, so it's not thread safe. But this is thread safe. And then this ARC, what you do in each thread, this one, what clone looks scary, you might say, oh no, my god, they're copying it. So if this is not just 3, but maybe let's say 10 million elements, one would think that this is actually copying 10 million elements for each thread, which might kill your memory. It does not. What clone does in the ARC is just increment the atomic reference counter by 1. And once each thread is done, it's decremented by 1. And once all threads are gone, wait, but not before. So you cannot end up with broken memory here. First, and then you?
I guess you can also use an iterator over immutable references. That should also work, I think, because every reference is immutable and yeah.
Actually, this is immutable already. So I thought that too, because that's how I would use it in Scala. I would use an immutable vector. Vector is immutable in Scala.
What is immutable? Are the elements immutable, or is the whole vector immutable?
Vector is immutable.
The threads, they are immutable apparently.
The threads, they're just reading. They're not changing it. But what could happen is that if the threads are running, the threads could take a while they're running. And the main thread, which allocated the memory, could end before the threads are done, and then it would free the memory, and then the threads would access memory that's already been freed. That would result in a crash. And this is what this ARC is doing. It's wrapping the stuff you want to use in your threads and keeping it alive and incrementing a reference counter to that vector internally. And every time you clone it and push this one into that clone into the thread, it increments the reference count by 1. And once the thread is done, it will decrement it by 1 automatically. This is the destructor of the ARC. And it goes out of scope here. It will decrement by 1. And once it's 0, the whole ARC, including what's in it, can be thrown away. Clear or?
I still don't understand. So you say it's immutable, but the threads push, you mutate the threads.
Oh, no. This thread, that's mutable, yeah. I was talking about this one. This is immutable, sorry. Okay. This is mutable because I'm pushing it in. This
Right.
is outside. This is not inside a thread. This is just in the main thread. This vector. This is just a handle to the other thread that I started, and that can go out of scope here. Because I'm iterating over here, it will actually go out of scope after this bracket, and then it will be gone. But you could not pass this, for example, to this is not pushed into the thread. A thread is spawned here. You could not push this into other threads as well and mutate them, for example. That would break. You had a question?
No, I just wanted to add that the problem here is not immutable access to shared state. The problem here is that Rust will insert deallocation code, and the problem here is that it's not clear when it's okay to make this strings vector. Okay?
Yeah.
You would want some kind of parallel map here instead of.
We'll talk about accessing maps. Now, even well, there might be other ways to do it. Like you could iterate. Maybe I haven't tried that. Iterate over the vector and then in the loop span a thread and just passing that element. But if you do it like this, you need to use the archetype.
One more question here. So am I right that the strings vector then on the stack, and then in the arc new we try to move it actually into?
No, vector is
also so it needs to be copied.
no, vector is heap allocated.
The vector
because it can grow dynamically. Actually, Guru Manda, I have a very long blog post about how this works, and I need to publish this. Almost forgot. So vector is heap allocated because you can during runtime add new elements to a vector if it's a mutable vector like this. Yeah. It's a mutable vector, and we are adding during runtime new. So this is heap allocated.
Okay. One additional remark to the RC type. That's a smart pointer. It's only a pointer underneath.
It's a thread-safe smart pointer.
Yeah, it's a thread-safe pointer. And it's important to know that thing RC encloses must be immutable. You can only share immutable data.
Might be true, yes. Yeah, that makes sense, yeah. So, but as I said, this was still, who has done anything with Java synchronized or in Scala synchronized volatile? Who thinks it was fun? I remember the company where I work right now, staring at with a very skilled colleague for hours at volatile and synchronized stuff, trying to figure out if it's actually okay or not. Code that is accessing and mutating shared mutable state. You have two phases. One, and after you're done, this is phase two. It's extremely hard to reason about. This is why many guidelines for many things. If you, for example, are in, if you read Java concurrency in practice, encourages you to use immutable code. If you read a lot of other concurrency books, they will always encourage you to use immutable code, immutable data structures by default. And I agree. Sometimes you will have to use shared mutable states. For example, you have a cache, you're writing a dictionary server, so English-Spanish translations, and you always want to keep the 10,000 most common words in the cache, but the rest in a database. You eventually have to mutate your cache. And there may be other ways where you, at least once in a while, want to update shared mutable state. Depends a lot on your logic and your program. If you're writing databases, for example, queues, in-memory optimizations, whatever. Then it always gets painful because you use too many logs, which might make your code safe. But you might also want to say, maybe I want to be faster, so maybe just use a volatile here, maybe use not enough logs. then maybe eventually once you move your code from a 4-core machine to a 16-core machine, weird stuff begins to happen. Rust has some help here. This is broken. The code is in GitHub, and it also has those comments. Also, the file name actually has the string broken in it, so you should know what's broken and not. Here, I'm counting the words in that vector. This is we do similar exercises for candidates that apply for a job at our company. We let dial, and well, we're trying to read a file is the end for many, but some get further, and then you count words. Here we're trying to do this in Rust, and this is the first idea. Again, we have the string. With a vector, we use a hash map, which has a string and a counter. What's the stuff doing here? That must have slipped in here when I did the slides. So let's look at the code. As you can see, I'm still learning Rust, so sometimes. Yeah, that looks much better. At the latest tomorrow. We use the arc again, and then I sort of use this counts variable, also put this in an arc. Clone it, do the counting. And join and be done. Let's have a look here. The counter is basically the entry. This is the stuff in the map. See, either if it's in there, use it, what's already in there. Well, you have a map that has the string and the counted integer, which is incremented. And the first time I say, if it's already in there, give me that counter, or if not, insert 0, and then I'll still get the counter back. And then I can increment the counter in that's pointing to the integer in the hash map, the value, increment this by 1. Unfortunately, it doesn't work. And if you have done any concurrency in Java or C++, you'll realize why it doesn't work. Because this is not an atomic operation here, and there might be several threads context switching in here, and then you might insert 0 twice for the same word, and then the results might end up in a mess. So this is broken.
Wouldn't you have to declare count as mutable? Counts as mutable in order to change the values in it?
I wondered that myself, but it works.
That's broken, isn't it?
But that's broken anyway. But it doesn't compile, so let's have a look here.
I'm not talking about the arc, I'm talking about the hash map.
Yeah. I'll get back. I think we'll have a look at the next. Let's see what the compiler says.
But the arc contents are supposed to be immutable as well, right? Or did I misunderstand what you're saying?
We'll also check this in a moment. Just a moment. Let's compile this and then see what it says. As I said, I'm still learning. So cannot borrow immutably borrowed content is mutable. And that is, if you're new to Rust, the borrow checker might scare you off, but persevere, and it will be your best friend after a while. But first you might have a difficult start. That's line 23. And this is actually, where's the mouse? Here. Because the insert already, they're only trying to insert something into the hash map. And it fails because The thing is, hash map is mutable here. But let's see how the working solution.
What was the error message again?
Just a moment, here we go. Cannot borrow immutable, cannot borrow content as mutable. And that means what it says. If you're trying to do is to mutate it actually. That's why it doesn't allow it to. But there's a working solution. This actually does work. So this is the hash map. And this is just the system appears once, the string easier is twice, and Rust appears 3 times. So how does it work? I tried to explain it yesterday to myself. I hope I can still explain it to you guys. What we do here, we are actually using that hash map and putting it in a mutex. And then, and this is the important part, we have to lock it and unwrap it. And what you get back after you lock it is something called a mutex. That is alive as long as the mutex is in use, and once it goes out of scope, it unlocks the lock. So you do not have to unlock the lock yourself. It's done once the goes out of scope. And then you can actually use this, and this is basically like a placeholder for the map, and then you can insert the stuff and can also change the question why the hash map isn't immutable. But
just an immutable reference to the hash map, or like, because
I think you cannot change the hash map itself, yeah, but you could change we can change the content. This is what this does. But the cool thing is, the Rust, with a mixture of the borrow check and the compiler and those constructs, know that you cannot access this unless you put it in a mutex. A mutex allows you to access the content if it's locked. If you don't lock it, it won't compile. So we can try that. And remove that. Arc counts, that was just counts. Just a moment. Counts, I think. Yeah, counts.
Don't you have to unwrap it?
Let's see. As you can see here, this is counts, and then I'm again using counts, wrapping. This is okay in Rust. You can use the same variable in byte. But because it's still a hash map in it, it doesn't go out of scope. Doesn't mean it's destroyed after that. So, what happens when we compile this?
Now counts is
yeah.
something different, right?
Counts is the arc. Yeah, the arc doesn't have. Yeah, that's why it doesn't work, because count here is the arc, and the arc doesn't have a method or function entry. But here, this counts as lock. It's basically unwrapping it, giving us the internals of the mutex, but protected by lock. That's why it doesn't work. So the cool thing about this is,
You comment out the second counts line. Shouldn't it kind of work? Comment this line and the line 14.
20
and 14.
14. This one.
I'm curious, the syntax thing should be
it's not going to work because you're cloning myself. Or cloning.
Yeah, you're cloning it and you cannot. Well, you could clone it. It's not just. Let's just compile it for fun because there's no method lock on the hash map. That doesn't work. Online?
30?
Ah. To one parenthesis is too much. Again. This basically, by the way, this asterisk is like dereferencing, similar to C, but this is not part of the well, you can do this for every type if you implement the deref trait. Mutex has this, and if you dereference a mutex, you get basically what's inside the mutex, what's protected by the mutex. Same with arg. So you can do this for your own types as well if you want to use that syntax. Again, then you have that as a problem again. Because if you don't, there's no way to get this working without the lock type stuff, which you shouldn't. So the cool thing about this is if you really have to use, shared mutable state, which then in Rust you know that you can do it, and this is actually cool because sometimes you want to do it and then you at least know the compiler has your back. What this does not do is from deadlocks. So if you're overdoing the locks and you have a deadlock, the Rust compiler does not help. There's some discussions about it on the internet. I'm not a compiler guy. Maybe somebody of you can answer this, but as far as I know, hard problem or might not be possible at all. I don't know, there's some discussions on it, and some say it could be done, but it would require a lot of overhead during. I'm not sure if it's done, but Rust right now does not protect you from deadlock. If you have a deadlock in it, it's still memory safe. A deadlock is memory safe. You're not messing up memory. You're just messing up your program. There was a question?
Yeah, how does, if you write like a comprised hash map, like can you pass that then to different threads?
There is some work on thread-safe data structures right now.
I just wonder because it's just like this, you need to use this structure itself as thread-safe.
If this data structure itself,
can you do it?
I think it can be done because somebody's working on it, but I have to admit that I do not know how it would be done.
And then the standard library?
Not the standard library has a few data types I can show you. The collections are pretty cool, but there's not much as far as I know when it comes to thread-safe data structures yet. Some people are working on stuff like that, and so this is probably coming in the future, but this is not easy to do. Now is this, you have sequence, you have a vector, you have a queue, a deck based on, what the hell? You have a linked list, which you shouldn't use unless you really need a linked list. You have hash maps, you have sorted maps, you have a map based on a vector, similar thing. You have binary heap, which is a priority queue.
They are bigger or in versions?
You can mutate them.
Okay,
So a persistent collection is also immutable, but very memory efficient. This is currently not in here. Maybe this is coming, I don't know.
If you have a data structure which doesn't need a look to be thread safe, you can tell it to the compiler by using some so-called marker traits.
Very good.
Send. And if you implement them, they are unsafe to implement. And if you implement them, you say the compiler Okay, and you can freely move it between threads.
This is very good to point this out. This is, I highly recommend reading the fantastic Rust book. It will also be available in the future as a print version from some publisher. I don't know when, but this will be printed. And it's very good, it's very up to date. These are the two trends that were just mentioned. There's a lot of other stuff. It's more, if you print the PDF, it's more than 300 pages already. The documentation for Rust is much better than for any other, for many other programming languages at this stage. Okay, let's continue. That it's easy, but don't overdo locks. Locks are not free. And depends on your program. You might want to use shared mutable state, but if you know Amdahl's law, it basically says the more sequential code you have in your program, the less you will be able to scale. If you have only 5% sequential code, you can at most use 20 CPUs. Let's actually, I think it's on Wikipedia. So let's just look this up. There's a nice graph there. There's law. This is it, I think. Makes sense? If your parallel portion is 50% of your code, then you can at most make as much as if the speed up will at most be twice, because half of it will be on one CPU and then only the rest will be able to run in parallel. So you can only speed up a hop. If 95% of your code is in parallel, your speed up either on a single CPU with many cores or across the cluster with many machines will at most be 20 times. So if you have a lock and only 5% of your code is sequential due to a lock, your maximum speed up will be 20 times when you parallelize it. So keep this in mind. That said, sometimes you might want to use a lock and it might be only a very small part. And then you know it's safe, but locks come with a cost. So this might still be better to try to be lock-free. And there are already projects developing lock-free data structures. Or you can use something and other things. Still, even if you're safe in Rust with shared mutable states, try to avoid it. Of course, it might be a good idea to do performance tests. This is so one last example. Then I think we're already, 1.5 hours. You can also do something that's a bit nicer for some problems. They are called channels. That are, as far as I know, they're similar to the constructs in Google Go, but I'm not an expert in Google Go, so I'm not comparing them here. But channels can be used. You have a sender and a receiver, and you can have many senders right now. What we're doing here we are counting, not counting each individual word. Here we are counting the number of occurrences of the string Rust. Again, we use our arc here, and then we're creating a sender and a receiver that looks a little bit like a pipe. U size is like an integer but portable. That's when I contributed to the Unix Rust library some stuff for POSIX message queue. I had a broken build on GitHub on a 32-bit system because I was using a 64-bit long. This is portable stuff, so it makes sense to use it here. Also, this is from the center. Here we are using several threads again, 3 threads. What we're doing in here is we're splitting it by white space, and then we're iterating over it, then filtering each member that has the name Rust, that is Rust, and then we're counting it. That might not be. What have I done? I just touched the wall. Cable? What's this signal? Is it dead? Huh. Don't touch the wall. Search. Now. That was a concurrency bug. Okay, I'm not touching this. Okay, but this is, the idea here is just we count up strings, and then we're using the sender to send this count. We're calling unwrap here because we basically, okay, please panic, and in real life code you might want to do better error handling here. And then I have the total count, which is 0. Then I iterate over my, again, for loop, and then for each one I use the receiver. And we have many receivers, many senders, one receiver, and we're calling receive each, and then we're increasing the count, and then we get the total count of us. And this is not broken, this does work. Oh, let me see, but it should. Threads was channels. Done. Count for Rust is 5. So as you can see, it's 5. So in Rust you don't need any unit tests. No, just kidding.
That's the wrong example.
Where's this 5?
That's the wrong example.
Ah. Yeah, I was here. Actually in the browser. So it's working, yeah. I tested this a lot of time. This is nice. You don't have to deal with logs or anything here yourself. It's actually easier. And this works if you have, and you're basically, it's a bit like map reduce. You could do something like the map part, and then you're reducing it to 1. There are projects in Quasar that build on that or give you more flexibility, so maybe this will be expanded in the future. But right now, this is already a standard library. It's stable, and it's pretty easy to use. So, we already 1.5 hours. So, just one quick warning. Who's using stuff like Cassandra or Neo4j or any other weird distributed system? Good. We do that too, a lot of work. It's fun, at least as long as it works. What Rust cannot do, of course, if you have a distributed system like a database, you have a client writing here, then maybe another client is reading, they are communicating among each other, you have replication factors, quorums, there's a whole lot of stuff that can go wrong here, like you can't read your own write, whatever. There's so many things that can go wrong here, you could fill a book. Rust cannot protect them. Even if you write this cluster, Rust would be very good language for writing a NoSQL database. And all the concurrency issues you have on this one machine, you could handle with Rust. Well, the Rust compiler can help you. And you will avoid memory problems, no GC, and it's not something a Rust compiler can help you with because it's for one binary. Actually, I don't think you can't do this with a compiler. If you know how to, you will be rich. So Rust can help you with this. Same, these things. If you have 5 Rust programs all accessing the same file on your Linux system, you need to do some external like file locking stuff. The Rust compiler can help you with this if you have 5 different programs. Shared memory, the same. Anything else, any shared resources that are outside the control of the Rust compiler, the Rust compiler cannot help you with. So external lock is necessary. Now this was a big, very short, small overview, not a big overview about Rust and Linux system programming. So what could this be used for? Databases, of course. Now there are a lot of databases written in Java right now, but C++ is getting more popular again because you avoid some of the garbage collecting issues. Rust could make it even easier. Queues, web servers, of course, big data like Apache Spark, which is a very popular big data processing platform written in Scala, running on a JVM. But they're also now going through a lot of trouble to actually avoid garbage collection process. Of course, if VMs, monitoring solutions, lots of other things. Of course, you have to keep in mind that the Rust ecosystem right now is not nearly as complete as the Java Scala ecosystem. So there are trade-offs. You might have to do extra work with Scala to take care of off-heap memory management, but you might still be faster implementing a solution simply because there's a lot more libraries out there. That said, with Rust, it's very easy to interface with C libraries. So wrapping them isn't too difficult, as long as they're good quality. If you want to dig deeper, Linux system programming is a huge topic. Actually, the first book I highly recommend is to everybody working on a Linux machine. It's all C, so you can have some fun porting it to Rust. This is 1,600 pages. It's huge. It's really huge, and it's one of the best books about software development ever written. The other one is much smaller. It's a, I think, 400 or 500 page book. It only covers some of the book at the top, but also very good explanations about file I/O, how processes work and signals work and stuff like that. With the source code, I'm not just talking about the Linux kernel here, but more like, for example, this project Nix Rust, it's on GitHub. It's very interesting if you're into Rust reading the source code. Also, if you want to do the low-level stuff, then you can see how unsafe is used correctly. So this is very encouraging. HQs is the stuff I contributed myself. If you find bugs, please send me an email or open a pull request for the project, even better. Here, funny bug. I think for one of those, I think it was the open code. Here you basically write C code, and I don't know which code it was. I passed, the last argument was an integer. It was a pointer to an integer, but I didn't, when reading the C man page, I didn't see the pointer sign. I don't know why. And then in Rust, I wrapped it, it worked, it compiled, and then in the unsafe block, I passed, instead of the address of an integer, passed in the number 1, which said the kernel, please write something to the address with. I haven't found a kernel that did this. But it crashed, of course, so you have to be very careful if you do unsafe. Another interesting thing, if there's a struct in C, for message queue attributes that contains those 4 longs. And you can wrap this. It's a C struct, you add this representation C. It's very easy, you do copying, debugging and all this stuff. Compiler implements this for you. Very easy, it maps to a C long, cool, but it crashed again with illegal instruction signal, something very weird I haven't encountered before. But I had never seen this error before I did this. And then after a while, somebody told me that in the Python message queue library, they had a similar problem. And actually, in addition to those 4, which we can find in the man page, there's a C array with 4 longs in it, maybe for padding cache lines, whatever. It's actually called pad or padding. I did not add that. Was tried to map to a C structure with 4 longs and that array, and then it ended up in a broken stack. So if you're wrapping this low-level C code, you can have a lot of fun. The cool thing is now, if anybody's using this, it is completely safe unless there's another bug in it. But you won't. You don't have to call the message. You pass in a message descriptor. No weird pointers in it, no character pointers. You cannot point this to any broken memory, nothing. And you don't have to wrap this in an unsafe code because this is all hidden in here. So if you call that stuff, you get all the guarantees the Rust compiler is giving you without the weird C stuff. I've even added some convenient functions because the message queue interface is pretty strange actually. So I've added some community. I will add more, there's still some stuff missing. But overall, this is a pretty cool library. Another one I recommend looking at. This is the last one I'm going to show you. Okay. So I need to, I'm not used to this keyboard. So this is a very cool library, but the same guy, actually, he's a very smart guy. There's also a talk on YouTube, or maybe even more, not than one, about this library. Metal.io, that is cool. It's not about Metallica, but this is what I told you that the standard library currently only has blocking synchronous I/O. This gives you non-blocking I/O using ePol. The documentation is getting better and better. There's some blog posts about it. In Mac, serial allocation, of course, non-blocking, high performance, well, of course it's high performance, and your thread safe channels. So this might be these two powerful, the one in the standard library. So this is definitely worth checking out. So if you want to write a new NoSQL database, and it seems like everybody's doing it, this is definitely a library you want to have a look at right now. So, I don't think we have much. Learn Linux, that helps. If you know, there's a lot of information, but you know the Linux tools and everything, how to, like PS top. These are the GitHub links. For the slides, this is my GitHub repo. Slides, I may clean up some stuff, but you can go there to get, if you find a bug, please open pull request. I already mentioned Nix-Rust, so have a look at this. And thanks for listening. Ask me, I'll be around. And sorry for the weird browser stuff. That's it. Any questions? Or proposals for new talks the next time? Proposal?
Hello. Is there a REPL for Rust now, or?
A REPL? A REPL?
Yeah.
I don't know any, but I think somebody is actually thinking about writing one. Well, maybe even, that might even be an look, because we have internet here. And almost all, not all, but almost all Rust projects are actually on Crates.io.
Does it really make sense to have a REPL for Rust?
I think it might be nice to have one.
Well, you have something like Play, where you can you have this Play Rust thing where you can put.
Yeah, there's this. There's.
Stuff.
But well, this Play, this is actually online, so it might be nice to have something local here. REPL. Here you go. Now it's a trait. What's this?
For Rusty.
Rust.
Rust and Rusty with an I.
Okay, let's have a look at this. Rusty. This one? Or with an I? Okay, not Y, I.
Or maybe not on Crates, on Cargo.
Google knows everything. No, of course, only if you know how to use Google. Strapple. This one. Here you go. 4 days ago, somebody is working on this. A REPL for the Rust programming language, a work in progress, as most Rust projects. That looks cool. I didn't know about that. So here you go. You have a REPL. There's a post somewhere on the Rust on the that's also interesting. Rust IDE. They added this recently. I think there's an Eclipse plugin already, which is decent. I use Atom, which is okay. Visual Studio, Eclipse. Here it is. Rust and IDEs. This is a recent addition to the Rust homepage. the plan, it's good, they have a plan. They are trying to improve the tooling basically for IDEs. Eclipse is a Visual Studio is also good. As far as I read, I don't use Windows a lot. You have plugins for those editors, and IntelliJ might also be coming. If you use Atom, so this is also necessary for Eclipse. This is basically a program that scans the Rust standard library and helps with code completion and everything. It's not Java style code completion awesomeness in IntelliJ, for example. But tools are getting.
Is there any unit testing framework or something integrated to?
That comes with the standard library. Actually, despite the awesome compiler, you still need to do some tests. So these are the message queue, and here are the tests for it. Normally you put them in a test. What have I done?
Test point to target.
Okay, crap. Sorry, I'm not. The mouse is really strange. So you can, for example, and this is built in the Rust standard library. You add this test, like annotation here, and then you can say cargo test, and then stuff is executed. And you have can have asserts here, like assert equal. It's not JUnit style powerful or Scala test style powerful yet, but it does most of the things you want. Any more questions? Think there's still drinks available? No pizza? If you get started with Rust, don't be discouraged by the compiler in the early beginnings, because it can be a bit, what the hell have I done wrong here? But normally if the compiler complains, it's only because he likes you. Yeah? It's really there to help you, and once you get used to the error messages of the borrow checker, it's actually fun. And besides that borrow checker, I think Rust isn't that complicated a language. It's might be more complex, I don't know, than Google Go. Some people are telling me, or maybe in Python, but it's, in the end I don't think it's that complicated. Maybe getting to use the different string types, one is stack, another heap allocated, and converting between those two and vectors of bytes is a bit of a mess. But you get used to that too, and other than that, it's not that complex a language, I think. Definitely not as complex as trying to understand everything that's in C++, which I have never managed to master.
Could you go back to one of the examples with the strings?
I have a lot of examples with strings.
It actually doesn't matter which one, just...
Okay. Then take a working one.
Yeah, okay, so when you declare that string vector, that seems quite verbose to me, that you repeat on every line the string : : from. I, as a programmer, am of course lazy, so is there a way to only write that once, for example?
Then you mean that string from?
Yeah. First of all, are you turning a string into something else, or are you making a string from something which is yet something else?
This is that string that looks like a Java string but isn't. This is a heap allocated string, and because the vector is heap allocated, we're also allocating the strings on the heap, and then you have to use something. I'm not sure if you can actually use.
Can you map it over a list of stack allocated strings, for example?
You could.
I mean, it's right.
Well, it's already 2 lines I wrote. I wrote it twice, and I don't really feel like writing it.
Yeah, you're right.
You probably could have a macro.
Oh yeah, you can do meta-programming, right?
But with macros, you can probably do almost anything in Rust.
It's not typeset?
Ampersand says it's a...
The end signal, because the
compiler. The macro does it.
already slice.
You're right. So
That's not a problem. You can also borrow stack allocated things. Shouldn't be much of a problem.
Oh no, I've only the broken stuff. So. Threads. No. Are back working.
Three strings.
Yeah. So this is because some things are still have to be done at one time.
So you have there in the for loop, you have
You're
0 to
0 for you, so you need
3.
okay.
No commas missing.
You could also use for that also works.
Here we need a comma.
3 is a normal expression.
Yeah, it's like a range. Panicked.
Did you save it?
What's wrong here now? Maybe I didn't save it. So yes, thanks for pointing this out. I'll try to update the slides.
But it should have copied more now, right? This is stack allocated?
No, it doesn't need to.
No.
copy.
It doesn't copy it? Okay.
This is not copying it. The clone, it looks like it's copying it because cloning says, yeah, make a copy like, I don't know, that sheep they want cloned and then you get a new sheep. Or something. But actually, no, even that sheep wasn't copied. What clone in an arc does is just incrementing the reference count atomically. So it would have been nicer to say increment reference count instead of clone, but clone is quite common if there's a clone trait and the clone trait is implemented for arc and it's just incrementing there. And when it goes out of scope, it's decrementing it automatically.
This lambda afterwards, right? This is a lambda.
This is a lambda.
And you have to move in front of it.
The move is basically taking what's that has a strings clone and moving it, that one clone, moving it into here.
Are there other options?
You do not always have to move it. Let's see what happens if you don't. But I think you have to move it here. Yeah. It's borrowed, so they're saying, okay, it's borrowed, you have to move it. But in some other, I think in another example here, mute. Where is it? I have it was the channel, I think. Where is it? It's no. Was count. Here, it's the same thing, and here I'm not moving it.
But here there are no free variables. So
No.
You don't use anything else.
No.
And so my question is basically if there's any, because it probably looks at free variables and then moves them. So my question is basically, can you do anything else then? Or is it?
Yeah, you can. You could use an iterator over strings, which gives you immutable slices.
Sounds like a good idea.
These
Yeah.
immutable slices could move into the threads without incrementing some reference counter.
So yeah, there are probably better ways to do this. I chose this example mostly to show you that the compiler is detecting concurrency bugs, so in that case, if you don't use the arc, potentially problems with memory being deallocated while some threads are still trying to access it. The best way to do it. That this is all just for demonstration purposes. This is not something okay, hey boss, let's write a new SQL database. I have some code. Let's copy it in it and add some SQL shell and we're rich. I'm sorry, that doesn't work.
One question. It seems that there is not a lot of Rust softwares written in Rust. I cannot find them.
Rust.
In Go, you have a lot of software.
Yeah, Rust is very new. There's this Crates.io. They have now more than 3,000 libraries. Not all of them are actively maintained. And many that are actively maintained are still under heavy development, like for example for HTTP2, non-blocking out, a lot of threading stuff. And for many systems like PostgreSQL, Redis, Apache, Kafka, I think for Cassandra there's something. MongoDB has an official Rust driver now. But the amount of libraries available for Rust is still relatively small compared to Google Go, which has been around much longer. And since Docker, everybody's somehow talking about Go. And it's not even close to where, for example, Java is. Well, it's easy to integrate C libraries, unless you pass integers as pointers, as I did. But it's still a very young thing. There are some companies already using Rust for production systems. And sometimes if you don't need a lot of extra libraries and all you need is standard library, maybe a few external crates that are relatively stable, you're good to go. But if you're going to still be much more productive when you talk about times to market, at least right now, using Google Go or Scala or Java or even C++, because the ecosystem is much bigger. But Rust is catching up quickly, and the amount of libraries that are adding and the ones that are actively developed and the high quality of those libraries, like the Metal.io library, is making this more and more interesting with every release. So Rust will probably never be as big as Java, I don't know, but probably nothing ever will be as big as Java. But I think it will occupy a certain space. There are a lot of, there are already libraries for web frameworks like REST style. Although Rust might even be better suited for actually writing a web server, a full-featured web server like Nginx. But a lot of stuff is coming, and I hope that in maybe 2 or 3 years, Rust will be much more common, and a lot of stuff will be written in Rust. And also, it will be used to access existing solutions. There's a Rust library that's already working pretty well, or Redis or PostgreSQL. But the ecosystem is still a lot smaller. But Mozilla is behind it, and I don't think they will stop working on it in the next couple of years. So I think the future looks pretty bright. But I would not necessarily think Rust right now. Particularly because for many of our systems, the JVM is perfect. We use Java in some projects, Scala, and that works. The tooling is very good. Java IDE is as ugly as the language might be sometimes. The tooling is just awesome. And Scala support now for IntelliJ and Eclipse is pretty great, most of the time. So still way behind all this. But it has some cool features that at the moment are unique to Rust as far as I know. I don't know anybody, maybe Swift is getting in going into a similar direction. I don't know much about Swift. But for example, Go has some similar ideas like the channels, but Go still is a garbage collector. And as far as I can, probably the type system might not be as strong, but I'm not a Go expert. I may never be one. So, but yeah. I think it's definitely even just worth having a look, because if you think about Rust and you learn about Rust, and then you later have to do something or want to do something in C++14 or C++17 in a couple of years, you learn with Rust can also apply to C++. For example, all this move stuff, there's move semantics in C++ now. The args, not the args, but the reference counter is like a shared pointer in C++. You have a box type as a heap allocated type is like a unique pointer in C++, more or less. And probably, maybe C++ will add something like arg in the future, like a thread-safe reference shared pointer. Maybe you could add this as a library. This is not something you need to build into the language. You can just add this as a library. So many of the things you learn when learning Rust, you can apply later to C, maybe not, but C++ definitely. So I think it's definitely, it's fun playing with it. So, but I would not necessarily say, okay, I'll build the new Google on Rust right now. Maybe in 5 years. Smart enough to build the new Google, you can deal with C++ as well. Another question?
I got a question. A thread in Rust is basically...
Right now, yes. There used to be green threads. And they changed this, is, I think, still available as a library somewhere, green threads, but this is operating system threads. So this is mapping on a Linux.
So if you would have to, if you would like to have a very large number of like lightweight processes, kind of like an Erlang higher level.
There is a library, actor library in Quaker. I don't know if this is still developed. It was just maybe proof of concept for some guys. It looks a bit like Akka, but much less powerful right now. Maybe they're still active, but you could build something like an actor system, like something lightweight, very lightweight processes on top of those threads. What Akka does in Scala, you can start hundreds of thousands of actors on a thread, 100, 200 threads, because the Akka system is just executing those lightweight actors that are just a couple of hundred bytes, I think, on the thread pool. So you could use this, use a thread pool, let's say, I don't know, execute something more lightweight on top of it and do the scheduling yourself. There's already there's a project in Crates for fork join, similar like the Java fork join, so a lot of those foundational libraries. So there's something called ThinkBox and eventual IO. There's a lot of stuff currently being built for concurrency. There's this more high level than low level threading. The cool thing is if you use threads and you have to, at least for logs when you need it, the compiler will help you. But you should still probably try to avoid logs unless you really need them. The Akka guys went to a log as possible because log is always a performance killer. So maybe in a year, or if I come back, maybe do another talk about Rust concurrency. I assume that in a year, maybe even half a year, I hope to do a talk on other concurrency features in Rust. There might be a lot of stuff to talk about.
For the threads thing, sometimes you can avoid threads by having something like reactor pattern like Neo does, where you just register your events and then you have this reactor thing which just handles everything.
Yeah.
And not in parallel, but one after the other.
You can do this like Redis. Like in Redis, they use an event loop in one process and they can handle hundreds of thousands of connections in one process. Normally then you're bound to one core, which might be okay, because you just could say you have something like of it that's starting 8 of those threads. If you have an 8-core machine, you start 8 threads and each has this event loop and you could scale like crazy. So you can combine it, and those event loops are normally a lot cheaper than doing threads all the time. The standard, the very primitive way it was done on the JVM was for each request to start a new servlet. Of course, they realized pretty quickly that's a stupid idea, so they implemented thread pools. But it took them a non-blocking, well, asynchronous, even later non-blocking IO to the servlet mode. I think it was 3.1 or 3.2 only. Of course, in Java, normally, if you want to do something like this, you use Netty, for example, which works for you. And MATLAB or Mio is going in the same direction. But Mio is very low level, but maybe some other, I think there's already another project building something on top of it, make it easier to use. So this is definitely, if you're building a system with a lot of connections, concurrent connections, Mio is the way to go right now, I would say. Maybe combining it with a thread pool or something like that. Please think about giving a dog. and learn how to use a browser.